等一下上课，如果你没有听到我的声音，你再开你的麦克风跟我讲。然后你有问题也可以随时问。那我们就要开始咯，然后记得去留言。So last time we talked about the green theory. The green theory, and the green theory is to change the double integral to line integral. Then we have one example here, right? The last example we talked about last time. So now we are going to talk about the next example, example 12.9. So you can use your handout to check the green theory. I cannot write anything here. Okay, so the example is the line integral. So you can try to use the green theory to transfer this one to double integral if double integral is easier to calculate. So you can see this one and this one is the function, and the target is x and y. The condition for x and y is every positively oriented simple closed path. So that means actually this example does not give you any condition for x and y, right? Because it is for every positively oriented, every, so no single condition. So how to calculate the line integral here? Because there are infinitely many such paths, that means no single
老师没有声音。
听到吗？ OK 好，那我从这题开始讲。Okay, so the example 12.9 is the line integral. And the path C is the closed path. The closed path is for x and y, right? But this example did not give you any condition because the condition is for every positively oriented simple closed path. So there's no like upper limit or lower limit like from k from 2 to 3. There is no such condition for path C. Okay, so you have to use green theory to convert line integral to double integral. Let's try to use this one. So the green theory, this function is f dx, right? F dx. This function is g dy. So the green theory, you have to use the partial differential for partial g partial x minus partial f partial y. You can check your handout before. and you do the calculation, you can find this one. Partial x means you don't have to consider y. Sine 2y is the constant, right? Sine 2y constant, and you have to see here, do the partial differential. And for this part, x is the constant, so you only have to do the differential for partial y, cosine 2y, so you will get this one. This example is a special case. The special case means the answer is equal to 0. So if the answer is not equal to 0, you cannot get the answer for this one. Okay, so because you use the green theory to calculate this double integral, then you find the answer is equal to 0, then you put the answer in the double here, double integral. This one is the question here. Example, the question is here, and you use the green theory, you can have this one. So the 0 here is the calculation here. So because you integral a 0, the answer should be 0. So no matter what is the path C, for every positively oriented path C, everyone is the same because the integral, the target function is 0. Any question? I give you 1 minute to write it down. Okay, let's go to the next slide. If you are not ready to write everything, please tell me. The next topic is surface integral. So previously we are talking about the line integral. It is a one-dimensional equation, right? One-dimensional. So for here, surface integral is for two dimensions, x and y, or not x and y, like u and v. So now we are talking about surface. A surface can be defined by a parametric function by using two variables. So you can see for every x, y, z, we are in a three-dimensional space. It is very different. We are talking about a three-dimensional space, x, y, z. Previously, we are talking about line integral, right? Line integral. The line is also in three-dimensional space, x and y and z, x, y, z for everything. X, y, z for line integral and the surface integral, okay? So for line integral, you have to compare line integral and the surface integral here. They are similar, but a little different. For line integral, okay, we can see here, for line integral, you only have to use one parameter t. The line is in three-dimensional space, so you use x, y, z. But it is a line, so you can use only one parameter t to represent a line in three-dimensional space. Okay, so here, the surface integral. The surface is also in xyz space, so xyz, still xyz, but it is a surface, not a line. So you have to use two variables. Here we use u and v. Unlike the line integral we use t, one variable t, but here it is surface, so we use two variables, u and v. Okay, so for this section, you will see u and v instead of t in previous text. So let's see some spatial surface, how to represent a surface like this one. You cannot draw this by yourself. You cannot draw this by hand. You have to use software. So here, example 12.15 tell the equation for x, y, z to represent this surface. So how to define this surface? First one, you can see x, y, z are represented by u and v. Can you find z is equal to xy? Right? Z is equal to xy. X multiply y, you will get double u, right? U squared here. And you will get cosine v sine v. Cosine v sine v is the two times angle. Sine 2v is equal to 2 cosine v sine v. Is the rule, right? So you can find z is equal to xy. So z is equal to xy. That means if you have a plane z equal to k, it will cut the surface at xy equal to k. If xy is equal to k, this line is a hyperbola, 双曲线. And secondly, if you try to put a surface, this surface, y is equal to x, positive or negative x. If you use this condition, okay, y is equal to x. You put this condition here, just here, you will get this one, right? You will get this one, okay? That means if you use this plane, y is equal to x, this plane to intersect or to cut this surface, you will get this one. This one is a parabola, 抛物线. So the first one is 双曲线, second one is 抛物线. So if you combine the first one and second one, this surface is called this blue word. It's like a combination of hyperbola and parabola. So it is very unique surface here. Okay, let's go to the next slide. What is other expressions for surface? There are several expressions you can use to represent a surface. The first one is called the level surface. Level surface like to put every variables x, y, z in one side of the equal sign in one side, and the other side is a constant. So like here, function of x, y, z, like this one, is equal to a constant, a single constant. So do you know what is the shape? What is the shape of this equation? It's like a circle in two-dimensional space, right? It's a circle. If the circle in two-dimensional space is like a sphere in three-dimensional space. So the center of this sphere is 1, 0, minus 4, right? Just check here. 1, 0, minus 4 is the center of the sphere. And what is the radius? You have to give a square root of 16. So the radius is 4. So the expression like this is called a level surface. The sphere is a surface. The sphere is like a surface in three-dimensional space. The other expression is like this. You can write a z equal to certain x and y. Z is equal to the variable of x and y. Okay. Next, what is the position vector? You can compare with the line integral every time, okay? So for the position vector, it is very similar. You can put an arrow here, because it is a vector. Put an arrow here. And also ijk, put an arrow at the top of R and ijk. You can see this equation is very similar, but the different part is uv. For the line integral, you have t, but for surface integral, you have uv. Okay, so it's like an arrow from the origin. Origin is 0, 0, 0 to the point x, y, z. It's like the line integral. We have talked about this before. And what is the simple surface? It's like a simple line, simple curve. Simple surface is like a simple curve. So that means at a different time, the surface is not at the same point. Yeah. So if R is equal to R, that means if you put a U1, V1 and a U2, V2 at a different position, but they are equal for a simple surface, this condition can only occur when U1 is equal to U2 and V1 is equal to V2. So at the different times, the surface does not fold over or intersect itself. That means the simple surface. It's very similar to a simple curve. Okay. So now you can only see U and V instead of T. Okay, so the next topic is to find a normal vector to a surface. This part is a little difficult, so if you cannot understand, you can ask me when we go back to school, okay? the normal vector to a surface. Let's see how to create a normal vector to a surface. And it is a surface, not a plane. I have mentioned this, right? Surface is a 曲面, plane is a 平面. So for surface, there are several normal vectors, lots of normal vectors. So if you want to find a normal vector, you have to give me a point. Like here, you can see this figure is a surface, not a plane, right? So for every point, if you give me different point, the normal vector should be different. So please give me a single point, then we can define the normal vector. So first one, the sigma, we give this symbol. The sigma is the surface, is this surface, is called a sigma. Okay, and you give me 1 point, P0. Okay, and the P0 is corresponding to U equal to U1, V equal to V1, V0, sorry. If you put a U0 and the V0 in the point, you will get a P0. Okay. So there are 2 steps to get a normal vector. First one, I have told you for every point here, we have 2 variable UV, right? If we have U and V, that means that is the 2-dimensional shape like a surface. But if we put only one variable, the surface will be a curve. I will explain this in Chinese later, okay? But please try to understand now. So for every point we have UV, right? But here we fix V at V0. So please see here is V0 and V0, right? So if we fix V as V0, this point will give you a curve, 曲线, not a surface. So like here, sigma U here, sigma is the surface, but if you fix V at V0, you will have this curve, not a surface, curve. Okay, this one, curve. And then let's have a tangent vector here. How to have a tangent vector? Just do the partial differentiable. Partial x, partial u, partial y, partial u, partial z, partial u. You will get a tangent vector at P0. So similarly, now I'm explaining to you how to get a sigma u and the tangent vector u0, right? So the next step, similarly, you will have a sigma v and the tangent vector v0. 好，我呢用中文讲一次这边，然后后面那个部分就是一样的，好吧？就是现在这里有一个曲面叫做 sigma， 那你要在这个曲面上呢找一个法向量，那这个曲面是弯曲的，所以你必须要固定一个点才会有一个固定的法向量。那你没有固定点的话，这个法向量就会一直改变，好，你就不知道在找哪一个法向量。所以假设我们现在取 P0， 就是这个点，好吧？取 P0， 然后我们要找 P0 的法向量。那这个 P0 是一个固定的点，所以 P0 就是在 U0 跟 V0， 你固定这个 U0 V0 带入 XYZ 之后，你就会有一个固定的 P0 在这。那首先呢，我们先把曲面变成曲线， 那怎么把曲面变成曲线？就是把 UV 当中其中一个点固定住。所以第一趴是把 V 变成 V0。如果你把所有的 V 都变成 V0，你就可以把一个曲面变成一条曲线，就是这里的 sigma U， 可以吗？这一条线。那它是曲线，所以它上面的切线也会随着不同的点而改变。我们就找过 P0 的这条切线叫做 TU0，就在这里。所以你要做切线，就是把 XYZ 呢对 U 作为分。那要注意一件事情，这里要写 U0，但是是第二个步骤。你第一个步骤是把 XYZ 对 U 偏微。偏微完之后，你会跑出一个纯粹是 U 的方程式。第二步再把 U0 带进去。如果你先把 U0 带进去，那你整条线就会是常数，因为 U0、V0 都是常数，你带进去就没有东西可以微分。所以首先你要做的事情是把 V0 带到方程式。V0 是一个数字，你就会剩下纯粹的 U 的方程式，再拿这个纯 U 的方程式对 U 偏微，偏微完之后再把 U0 带进去，就这三个步骤，你就可以得到这个tangent vector。好，我往下，你应该抄完了吧 ？Okay, so for part B, part A we fix V equal to V0, right? So for part B we fix U equal to U0. Then you will get a curve sigma V. You can compare the step A. Step A is to fix V equal to V0. You get a sigma U. Step B, you fix U equal to U0. You can get a sigma V. Okay, so everything is the same. So you have curve sigma V, then you will find a tangent vector. This T is vector. You can put the arrow. Okay, put the arrow. So the tangent vector V0, how to get this? You cannot put the V0 first, right? You have to do the differential. So partial x, partial v, partial y, partial v, partial z, partial v. After get everything partial differential, then put the v0 inside. So first step is to put the u0. Second, to do the differential, and then put the v0 inside. Okay. Let me see the figure. So if you have the tangent vector t u0 and the tangent vector t v0, you can use these two vector to find the normal vector using what? Using crossed cross product. So normally the two tangent vector should not be the zero vector. And these two vectors are lined on tangent plane of the surface at t0. So if you do the cross product, you will get a normal vector. So just remember this equation and this equation, okay? We will use this tangent vector and this tangent vector. Okay. The cross product for these tangent vectors is normal to the tangent plane. 切平面. So we are trying to find the normal vector to the tangent plane at P0. Okay, P0 is important. You have to give me 1 point, then I can give you a normal vector. So as I mentioned, the normal vector we use n here. You can put the arrow, okay, arrow for every bold later. So the normal vector is n at P0. Okay, P0. So you can put a P0 here. It is the cross product, YG cross product of two tangent vectors. You know how to calculate cross product, right? So just put a TU0 here and a TV0 here. The only different part is partial U and the partial V. Yeah. And do the calculation here. You have to remember this. There is an easier way to memorize this equation. Okay, can I go to the next part? Anyone have not finished? Okay, so make this vector easier to write so you can memorize this one. This one is called the Jacobian of two functions. I think I have told you before the Jacobian of two functions. Let's see how to define this one. It is the partial differential, and you put f and the g and the uv. You can just memorize this one, but you have to know how to write this one as this one, right? So let's see. F and the G here. Partial F and the G, F here, G here. Partial UV means the U here, V here. Okay, so partial FG, partial UV means you put a partial F, partial U, partial F, partial V at the first row. And the second row, you put partial G, partial U, and the partial G, partial V. Okay, and you have to calculate this one by using this one multiply this one, these two, the multiplication of these two minus multiplication of these two, just here. Okay, you have to know how to calculate the Jacobian of two functions. Then the normal vector can be like this. So please try to memorize this one, and understand how to use this one to write like this one. Okay. We will have example later that will be easier to understand. And also how to memorize this one. You can see IJK means the direction of X, Y, Z, right? And you can find for the direction for X, there is YZ. For the direction for Y, there is ZX. For the direction Z, there is XY. So you can write XYZ in this order, XYZ. And if you want to see here, just delete X. You will have YZ. And if you want to see here, XYZ, delete Y, you will get ZX. If you in order XYZ in order XYZ, and delete Y, you will get ZX, not XZ. ZX, not XZ. Okay, and the last one, delete Z, you will have XY. You can try to memorize this equation by using this way, but if you have better way, you can use your own way to memorize this one. The normal vector is very important for surface integral. This part is very important, so you must have to memorize this one. It's very important. Okay. I can write something. I mean, if X, Y, Z in order, X, Y, Z in order, I cannot write anything. Okay, give up. Again, if you have any question, you can ask me in school. Can we go to the next part? Okay, try to memorize this one. One example, let me finish this example before class dismiss. Okay. This is a surface. This is a surface. This surface is called an elliptical cone. And this is the coordinate function. The surface is in three-dimensional space, so we use X, Y, Z. We use X, Y, and Z to represent every point at the surface. Okay, and because it is the surface, so there is U and V, as you can see, UV here. We use the variable U and V to represent every point X, Y, Z at the surface. Okay, U and V. And the A, B are positive constant. So this example, try to write a normal vector. As I mentioned, if you want to find a normal vector, you have to give me a point, right? A point. Because at the surface, there are several points. And for different points, you have different normal vectors. So please try to find a normal vector at this point, P0. So for this example, P0 is important. The first step is to use P0 to find U and V. You don't have to write every word in your handout. First, let's see why it is called a cone. The function x, y, z you can see here. And also, please see if these three functions fit this equation. You can check. Z is u, right? So z squared means u squared. And x is au cosine v. So if you divide au cosine v by a, you will have u cosine v. Similarly, y over b means u sine v. So u cosine v squared 8 u sine v square, you will have u square. You will have a u square like z square. Okay, just put these three functions inside. So this kind of equation means a cone, and the major axis is z. Okay, so this sentence is trying to just want to explain why this coordinate function can draw this kind of surface, elliptical cone. The parametric function, parametric equation for this cone is like this. Okay, then please calculate by yourself because I cannot write anything here. P0 is from the example. Okay, the question should give you P0. Question P0. From P0, you can obtain U0 and V0, right? How to do this? You know how to do this. P0, you have x, y, z. So please write x is equal to this one. X is equal to this one. Y is equal to this one. Z is equal to this one. So which one is easier to calculate? Z, right? Z is equal to 1 over 2. Z is equal to U. So you can directly find U0 is 1 over 2 because Z is equal to U. For P0, this one is Z0, U0, U0 here. Okay, so how to get V0? Try to use X over Y. It's okay to use either one. Let's use Y, okay? Y is equal to B over 4. Y is equal to BU sine V, right? So U sine V is equal to 1 over 4. U sine V is 1 over 4. U is equal to 1 over 2. So sine V is 1 over 2. So V is pi over 6. You can calculate by yourself. Okay, try to use x0, y0, z0. You can get u0 and v0. It is the first step because you have to have u0 and v0. Then you can calculate the normal vector as I mentioned before. So just put these two. Let's see how to calculate a normal vector. Use Jacobian. So the first one for x direction. For x direction, we can have partial yz, partial uv. So partial yz, partial uv, use Jacobian component. You can display this one as this one, okay? And this one is u0 and v0. Please don't put this first. Calculate this one, okay? Y is BU sine V, okay? Y is BU sine V. So partial Y, partial U is B sine V, okay? Z is U, right? Z is equal to U. So partial U, partial V is 0. Again, Z is equal to U, so partial Z, partial U is equal to 1. Maybe you can put a 1 here. Partial Z, partial U is 1. And a partial Y, partial V is U cosine because Y is BU sine. So partial Y, partial V is minus, is BU cosine, no minus, BU cosine. Y is BU sine V, so partial Y, partial V is BU cosine V. So first calculate this one, then put a U0 and a V0 inside. So this one is 0, right? This one is 0. So u is equal to 1 over 2. V is equal to pi over 6. So cosine pi over 6 is to square root 3 over 2, right? And you multiply 1 over 2, multiply b and multiply minus, you will get this one. Please calculate these two. This one partial zx partial uv is for the y component, right? Is for is for j, ijk, ijk. Here, partial zx partial uv is for j. So you display this one, use Jacobian, you will get xy, zx partial uv, right? Zx partial uv minus xz partial uv. So just check, z is u, x is au cosine v. Okay. X is au cosine v, z is u, so you will have this one. And after find this one, put u0, v0 inside, you will get this one. Similarly, partial xy, partial uv is for the z direction, is for k. So again, you calculate and put 1 over 2 and a pi over 6 inside. Last, you will get this one. We please come back at, because you have to write it down now, so come back at 2:15, okay? 2:15, we will start our next class. If you have any question, you can write something in the board. Sorry.